So I'm cleaning shop and I get my rocks out, some of them anyway, some that I cut, some opals. I'll open them up here in a minute. I'm looking at this because I found it. It's all gubby, and going, hey, man, look at this. So it's a 1906 silver dollar. My grandfather was driving a horse-drawn fire engine in San Francisco that year. They came in through the back door from Australia looking for gold. My dad's family, anyway. And here we are. We've got a 1906 P Philadelphia. And it looks pretty good, except the gubby shit, from laying around in my shop. Might not be an old one. I don't know, man. It does appear to be silver, though. It's not fake. This is a magnet, a very strong one, and it's not magnetic or anything. So I think it's silver. Feels like silver. And that's not like one of those layers of stuff in there. That's shit from my laboratory. I got hemp seed oil on literally everything. Okay, so we're gonna unwrap my Uncle Ricky's Radical Rocks. So this is a wood opal from Banten, Indonesia. From my friend, this is probably, I think, from ASEP Kernia. ASEP is a really, really good guy to buy this stuff from because he cuts it himself. He didn't cut this, he cuts opals. And when he goes out, he buys them from the mine. He buys them rough and then brings them back, sells rough, and cuts them himself. And so he buys the best. And this is the way the stone goes, actually. You can see that the colors come out better. Get a little closer. Yeah, it's gubby from being in my shop. Sorry. There's hemp seed oil on everything. And I probably hadn't really finished these as well as this one might be. I was running out of opal kind of on this one. This one had a lot more color to start with, but it is beautiful. This one is a really nice one. So, cool McDoodle, huh? I like rainbows, man. I like rainbows. Here's a little diamond, a little starfire diamonds. Not cool, huh? Diamonds start out kind of, at least these kinds from the fault line, start out as little cubes. So I want you to think about sand, right? Everybody thinks sand is made out of silicon dioxide. Silicon dioxide cannot form cubes or squares or right angles, right? We've got right angles here created by right angle by a square. Can't help it, right? Squares have right angles. Okay, now think about every bit of sand you've ever seen. What shape is it? And quartz is supposedly hexagonal, which means it's got two equal axes that are perpendicular to each other, like that, and one long axis. Squares, of course, have three equal axes. Okay, so what we have here is a piece of carbon, and this is very, very light. It doesn't weigh very much because it's just carbon. Right? And they feel kind of plasticky almost. I've had this big old ring. It looks like something that came out of a bubble gum machine, you know? You got a big old thing about this big round. And I thought it was plastic. I did. I checked it yesterday. It's not. It's this stuff. People call it quartz, but it's not. Just simply not, because it's certainly not hexagonal. Hexagonal and cubes are mutually exclusive. So I know a little bit about rocks, a little bit. Been looking for them. I don't know. I walk. My father took me to a place in West Germany when I was there, 1960, 61, 62, and beginning of 63, to a place called Idar Oberstein, and it was the Roman gem capital of the world. And I saw a guy cutting a black opal. Probably the only place in the world in 1960, other than Australia, you could find black opals. Unless you lived in Indonesia, in which case they knew about these, but nobody else did. So I didn't until, about 7 or 8 years ago. Isn't that something? So I've got better ones too. And you know what this is? It's silicon carbide. I didn't shape it like this. It just came like this. Silicon carbide is what makes up the mountains behind my house. It's what makes up most of the mountains in the entire world. It's light. very light, like a diamond. And it has about the same melting point up there, way over 3,000 degrees Celsius. Diamonds precipitate out of molten rock first. They have the highest melting point of all of the stuff, the most common stuff on planet Earth. And they form in every fault line in the world. And the fault lines are cracks between silicon carbide, which is the basement rock for almost everything. And this has that really, really high melting point. The lightness of silicon, of carbon, but I can machine it like a piece of steel. It's lighter than aluminum. Stronger than steel times 10 bazillion because it's got double covalent bonds like a diamond. But because it's got silicon in it, it's not, and other things, right? It's got a lower melting point, so there are other things that are coming out of the melt that get carried into it, things like uranium and stuff like that. Tungsten, notably. Titanium. But they're minor, they're trace constituents. These make up like 98% of the world's basement rocks, along with AUPT and AUPD. And molten rock is molten because it's radioactive. That's what makes it hot. And there's no fires of hell burning down there. Nobody lit the fire anymore. It stays lit all the time because it's the radioactive decay of radioactive isotopes in the molten rock, semi-molten rock. And underneath of our feet, you see how this had color all the way across once upon a time. And the color just forms like on the very outside on some of these, most of them actually. So this was kind of a learning experience, man. It was a really nice one. And I went a little bit too far because my fingernail is thick compared. If you took an orange and you polished it really well and put a layer of wax on it, that's about how thick or thin the crust of the Earth is compared to the molten part of the planet. The semi-molten mantle is 10,000 kilometers deep. The crust of the Earth is about 55 kilometers. It's just like a thin skim on the top. And we're kind of like a little crust of stuff growing on the outside. You knew that, probably, right? Crusty in the morning. I'm pretty crusty. Feeling crusty. All right, so anyway, so guess what the moon is? Take a wild guess. It's actually mostly AUPT and AUPD in basalt, right? Basalt has these bubbles in them, right? Except they're not gas bubbles. They're hoppers in the planes of cleavage. this is just the crystal formation. It was forming this way, floating in rock, in molten rock, right? Very light, and so it just floats. And it was floating this way. This was the bottom, and that was the top, and it was growing this way. And if you blow it up, you can see where it was growing. And you can also see that it's made out of little cubes and squares with hoppers. That is, they go inwards. And what you're looking at is hoppers in a cubic, face-centered cubic crystallization. Now it's not a whole bunch of little crystals, just one. It's just one. And so this whole thing is one thing. It's a molecule of silicon and carbon joined together with double covalent bonds. They don't come apart. They don't stretch. They don't bend. They're brittle, you know. I mean, but they're tough too. I mean, they are seriously tough, and we can build things out of this. I think the anomaly sticking out of New Mexico sideways is in fact made out of this stuff. I'm pretty sure. So, it's what you make spaceships out of, y'all. So we can go to the stars. Peace.